Okay, in this video, I'm going to be explaining the unit circle. So the unit circle is a circle with a radius of 1, and it's pretty important for trigonometry. And the way it's used is we make triangles within the circle and use its degrees, and in a later video I will show how this helps with graphing trigonometric functions. So to start with this, we're going to look at a triangle over here, and basically we're going to understand how cosine and sine are related to this triangle. So here we have cosine of theta. We have the angle theta, pardon me, and if we look at what sine of, this should be 1, sorry. If we look at what sine of theta is equal to, we see since sine is equal to opposite over hypotenuse, it's equal to the opposite, which is y, over 1, which is just equal to y. And if we do the same thing with cosine theta, it's going to be x over 1, or x. And that means that in this point over here, this point is going to be equal to cosine theta sine theta. And also write it down here. So this is going to be equal to cosine of theta, and this is sine of theta. So now let's look at the actual triangle. And first let's understand quadrants. So, and quadrants are represented by, they're split by the x and y axis. For example, that's a quadrant, and that's a quadrant. So these each have names. This is quadrant 1. This here is quadrant 2, and quadrant 3, and quadrant 4. So when we're working with the unit circle and the quadrants and angles, we're going to be moving counterclockwise in the circle as the angle measure increases. So in each quadrant, there are going to be 3 triangles, and I'm just going to kind of draw some of them in here with 3 different colors. And I'll just do quadrant 1 for now. So here in the blue triangle, let's start with blue. This measure, the measure of theta in our case, is going to be equal to 30 degrees. It's equal to 30 degrees, which in radians is going to be equal to pi over 6. And what's special about the unit circle is here is going to be equal to the square root of 3 over 2, and then comma 1 over 2. And that means that that x here is square root 3 over 2, and the y is equal to 1 over 2. And I'll show why that's important in a second, but let's try the red one. This one is going to be equal to 45 degrees, or pi over 4 radians. And here, it's actually pretty simple. Square root 2 over 2, square root 2 over 2. And now, in the purple one, 60 degrees, which is the same as pi over 3 radians. And this one is actually a flipped version of the 30 degree, and it's 1/2, comma, square root of 3 halves, square root of 3 over 2. So you might be wondering, why is this important? So it's going to be important when we're graphing sine of x and cosine of x, because, like I just mentioned earlier, sine of theta is equal to y, and cosine of theta is equal to x. So if I take 30, for example, 30, here, let me do this in the blue color. If I take 30 degrees, or pi over 6 radians, I can tell based off of this in the point where it intersects with the unit circle that cosine of 30 degrees, or cosine of pi over 6, is equal to square root 3 over 2, which, because of what we saw, how x is cosine of theta, and sine of 30 degrees is equal to 1/2. And I'll show you in another video graphing the graphs of sine of x and cosine of x. But let's just go ahead and look at the other quadrants. And I think you'll start to see a pattern here. I'm just going to do all of these in the same color. And there we go. This one right here is going to be equal to, well, we see here that angle is 90 degrees, and we go another 30 degrees over, so this is 120 degrees, or 2 pi over 3 radians. And this point, you might be able to guess based off of these trends that we saw in the first quadrant, except it's going to be negative 1/2 square root 3 over 2. And that's because we are now in the second quadrant, so the x values are going to be negative. And then here, it is square root 2 over negative square root 2 over 2, comma, square root 2 over 2. And that one's 135 degrees, or 3 pi over 4 radians. And here is going to be negative square root 3 over 2, and then 1/2. And that's going to be equal to 150 degrees, or 5 pi over 6 radians. And you might be able to figure out the rest of this unit circle on your own. Here, there's going to be negative and negative, then negative x and negative y. Here it's going to be x and negative y, where here it was x, y, and here it was negative x, y. But basically, this pattern will continue where it's just 1/2 square root 3 over 2, square root 2 over 2, square root 2 over 2, square root 3 over 2, 1 over 2, and that's just going to keep repeating itself. So that makes it easier to memorize this unit circle if you memorize this first quadrant over here, and then you can like think of it in your head and kind of imagine the values of the different triangles. The last thing I'm going to touch on for this is the axes. So this purple here, this is going to be 3 pi over 2 radians, or 270 degrees, because it is, because, let me find a new color, because here it's equal to 90 degrees, or pi over 2 radians, and then you shift this way, and it's 180 degrees, or pi radians, and then 3 pi over 2, 270, and then you come back to the start, and this can either be 0 pi, 0 degrees, or 2 pi, 360 degrees. And because of the way that this, like here, how it continues, like it goes 2 pi and it resets, that's why you get the shape that you will for the sine and cosine functions. So this has just been a very brief overview of the unit circle. I hope it's not too confusing, and I hope you learned something. Thank you for watching.